So here we go. What page is it on, Lily? 582. So you got a new book. If not, then you need to be using the online book at the beginning of the year. If you need access to an online book, just let me know. I can set it up. Same with you. If you need access to an online book, we can get it. But if you have a book, then you're good to go. Yeah. All right. So page 582, and let's take a look at number 2 on page 582. Let me a little bit. All right. When you look at that, it gives a picture of. Are those rectangles? Do you say that they're the exact same size? Looking at that picture. All right, so I'll do my best here and see if I can recreate a picture that has 2 rectangles. And we'll say the exact same size. So that means it's 5, 5, 5, 5, 2, 2, 2, and 2. Same size. All right, if you're going to prove, though, that these are a dilation, yesterday on the video that I did for you, it's really important you know from which one to which one. Okay, you can't just say it's random. Doesn't matter which order you're going. Does matter. Does matter. Okay, and then you have to make sure that the corresponding. This is kind of the big idea. The corresponding sides. We all know about that. Corresponding sides. We had that a lot in triangles. Okay. Corresponding sides are in equal ratios. Okay. Now, what's a ratio? A ratio is as simple as it gets in math, is just a comparison of 2 numbers. That's all a ratio is. It's comparing 2 numbers. Comparison of 2 numbers. That's all a ratio is. So for instance, 3 to 4. That is a ratio. Another word for a ratio? Fraction. They mean the exact same thing. So ratio and fraction have the exact same meaning. Okay? Now you're getting the idea. So when we start thinking about a dilation, if we're going from larger to smaller, it doesn't mean they're congruent. It just means they're in the same ratio, that this side to this side shrunk at the same rate. That make sense? All right, so this one's pretty simple. Yes, this is a dilation. They look exactly alike. It would be probably 1 to 1. That would be the ratio. That's another way to write a ratio, is like that. Or you could write it. Got it? Simple. All right, let's go on. Take a look at number 3. All right, now I'll see if I can build. These look like building blocks, don't they? Okay, so let's see. We got a little bitty one over here. Then it goes up and then over and then over and then down. And then over here we got a little bigger one. Then it goes over and it goes up and it goes down. Why would you say that these are not a dilation? What makes that? What if you're explaining that? How would you explain that that's not in dilation? Yeah, I would too. If you look at this carefully, let's say that this has a length of 1, and then let's give this one a length of 2, right? And so those 2 sides would be in a ratio of 1 to 2. Now, I'm not getting a ruler out and measuring it. I'm just saying that they're not the same. Okay? Whereas if I look at this one from here to there, let's say that just has, I don't know, we'll say it's 4. Isn't that the exact same length, though, as from here to here? Again, I'm not measuring it with a ruler, but doesn't it look like it's the same? Okay, so here we have 2 sides, 1 to 2, and then 2 other sides, 4 to 4. Are those equal ratios? That makes sense? So these are not equal ratios. So we would explain that this is not a dilation. Not a dilation. Because, same reason that we said it, they were here, because corresponding sides do not have equal ratios. That's the explanation. Does that make sense? Is that a little clearer than as you were going through the homework from yesterday? Does that make sense? All right, let's take a look at another one. Let's go to number 5. We're going to do 2 more. All right, number 5. Cassie, can you read it aloud for me?
Square A is a dilation of square B. What is the scale factor?
No, you don't need to. Okay, so there's square A. Here's square B. I'm doing my best trying to get it somewhat close. Here's square B. Not bad, huh? Okay, now, isn't this top side up here, isn't that 35? Yeah. And then this side over here?
No, the side is 28.
Oh, thank you. 28. Everyone okay there? Coffee, you got it? Okay, so now, if it says that it's a square, Tiana, what's one of the parts that we know that's true about a square? All 4 sides are congruent. So if that one's 35, then so is this one. If I'm thinking of corresponding sides, then I think, okay, well, this side here is 35. So we're going A to B, right? Isn't that how she said it? A is a dilation of B. A to B. Okay, so this is 35. And then what's the corresponding length of B? 28. So now that's remember, that's a format for a ratio. That's one way to write it. Or we write it like a fraction. 35 over 28. And then always we got to reduce. What are the whole numbers, the factors of 35, that are also factors of 28? Factors of 35, I know, are 5 and 7. So that could be 5 times 7. And a common, now 14 and 2 we don't want to use because that doesn't have a common factor that we have up here. But what about 4 and 7? That would work. See why we have a common factor of 7? Man, this is back to algebra. Maybe even before. And so what do we end up with? 5 over 4, numerator over denominator, which I think, is that C?
Yeah.
There you go. Now, I could see how somebody would write B as the answer. Because I switched it. You know what I mean? But now you see. Questions? Got it? Got it. Good. Okay, let's turn over. Let's go to number 16. Let's go to number 16. Didn't we have to do 16? Okay. 16. All right, it says, you work at a photography store. A customer has a picture that is 4.5 inches tall. All right. The customer wants a reduced copy of the picture to fit a space of 1.8 inches tall. Okay, what do we have? 1.8 to 4.5. Got it. What is the scale factor you should use to reduce? So we're going from larger to smaller. Right? If we're reducing, so we're going to scale factor, reduce. That's a key word. I'm going to write it down. Reduce means larger to smaller. So if I'm thinking of a of the term scale factor. That's the term we haven't talked about. But basically, that's just a ratio. That's all it is. Okay? And if we're going from larger to smaller, would that scale factor have to be greater than 1 or less than 1? Is it greater than 1 or less than 1? That's the question mark. Why do you say it's greater, Cassidy? Now think about that. I like what you're thinking. However, I think you got it backwards. If I'm going from something larger to something smaller, would I have to multiply this by a value of 3? Wouldn't that make it 3 times bigger? Ah, that's right. Does that make sense to everybody? I'm sure if Cassidy, does that make sense? So I need to make sure when I'm done that my scale factor has a value that's less than 1. That's a fraction. Does that help? Good. Okay, so now what were our decimals? 1.8 and 4.5. Okay, so there, I just started knowing that it's going to be less than 1, so I'm going to put the 1.8 in the numerator. Now, how do I reduce a fraction like that? Well, the first thing I have to do is get rid of the decimals. So I'm going to multiply everything by 10. I'm not going to show that work. So that's 18 over 45. Now I need common factors of 18 and common factors of 45. They are 9. And so this would be 2 times 9 and 5 times 9. The 9's reduced. That's why I'm doing that. And I end up with a scale factor, the ratio, of 2/5. So if I have a photograph, here's my photograph, and I wanted to fit it on a postcard, I need to multiply it by 2/5. Does that make sense? That means each side is going to be 2/5 the length of the other side. If I were just thinking that it was a square, now not many are squares, usually photographs are rectangles, right? But let's just say that it was a square like my picture. If this were 5, 5, and 5, then these would all be 2, 2, and 2. That make sense? We good? All right. Does it clarify some things you might have had some questions on from the homework as you watch the video? Okay, good. So here's the assignment now. No change in the assignment, but I want you to finish off the problems. If you're already done, great. Go ahead and submit them on Canvas, okay? Today, right now, like in class. And if you use your phone to do that, I have no problem. Go ahead and use your phone and get it submitted. Okay, but I want you all to get it submitted before you walk out. Got it? So finish your homework. If you don't get done, then you can turn it in. That's when at the end is when it's ultimately due. Questions? Okay, I'm going to stop the recording, and then I can work with you one-on-one. Okay? All right, virtual students, good luck. Any questions, you can email me.